Thanks in advance for watching this video. In this video, we would be covering a concept called small table threshold. Before I explain what is the small table threshold, let me give you a little background of few important components of a computer. If you are familiar with the CPUs, you would know that CPUs won't work directly with disk. CPUs are not going to work directly with disks. Whenever you want something, some kind of an operations to be done by a central processing unit, this guy, CPU can only work on memory. In that case, what you would do? You would do an IO operation to read data from disk to memory. What is the basic IO, basic input output operation size? That's actually your block size. Some databases calls it as a page size. In Oracle, it's a 8 KB. As of now, it's a default one. If you have, let's say, customer table here, right? Customer table has, let's say, 10,000 records, which are like 100 blocks. It might do somewhere more or close to 100 IOs to read entire this table from disk to memory. Let's say you have done this select statement from customer. So if there is no index, of course you are reading entire table data, so it has to do a full table scan. So it would read all these 100 records, 10,000 records, the 100 blocks into a memory, right? That's 100 IO. So at the same time, if let's say another production user comes in, let's say Chris comes in and runs the same select statement immediately, just within a fraction of seconds after you ran, right? Now, as far as the architecture now goes, you have a customer table here on a disk, which is 10,000 records, 100 blocks. You even have the similar copy here, 100 blocks. Now, the moment Chris fires the similar query, the CPU finds all the requested blocks for the table in the memory itself. So Chris gets advantage because of your initial query, right? Now we call this memory area in Oracle as SGA, System Global Area, where you have buffers. That's where it stores, right? Unless using some algorithms, the data gets flushed out of SGA, it sits in SGA, right? As long as this block sits in memory here, whoever subsequently coming and using the same table, they will get benefited, right? But my understanding of that same concept changed after I learned about a concept called small table threshold. What used to happen is in my production environment, there are some chatbots which runs a specific select statement as part of some data extraction once for every 5 seconds. It's a very simple thing. It runs every 5 seconds once. The select statement runs and it extracts the data, something like any processor transactions count, let's say. For example, something like select count star from invoices table where record status equal to, let's say, stuck. It wants to find out if any stuck records. Stuck means it's loss of business, right? Slowness in the business invoicing. So all it does is at every 5-second interval, it used to run this select statement, right? If it's keep running, let's say if I take 5-second interval like this, in a minute, it used to run for how many times? 12 times. Now, when you run it at the 0th Second, let's say it does a full table scan if there is no index, and it's let's say all disk IOs. When it's trying to run in the next within a fraction of 4-5 seconds, my expectation was it should go through a SGA, no disk here. But what used to happen to my surprise is every time it was doing a disk IO. Table is very small, hardly 1 GB or so. But every time it is doing a full table scan, yeah, of course, not full table scan. Every time it's doing a disk IO, it has to be in SGA, right? If some query is running that frequently, if the blocks are like a hot blocks. You agree? The hot blocks has to stay in SGA. That's when I figured out about the small table threshold, right? Now, what is the small table threshold? Let me show you a query that talks about it. So here I have an Oracle 19c environment on 7.5 Red Hat release installed. So this output gives me a number. This number is number of blocks. As per this parameter, if your table size in a blocks is less than 702, then the table is considered as a small table. If it is more than 702, it's considered as a large table. It's not exactly 702, somewhere like 5-10% here and there. Yeah, but this is a parameter that distinguishes between small and large tables. So what is the impact of this kind of a distinction? I will show that through this exercise here. So generally the small table threshold value is around 2% of buffer pool size. Now we would explore the small table threshold using two different approaches, using set auto trace on and using these NSMTIO non-smart IO trace. I would be sharing these exercises link in notes section or a comment section. So just concentrate, no need to take any notes. So let's first create a small table, right? Let me drop if I already have this table. So here I am creating a table which has only 2 columns. Now I insert some data into it. Then let me collect statistics for this table with 100%. So let's check out. It has 200,000 records. All are error records or stuck records. And it occupied 496 blocks. If you look at this 496 is, let me put it here. Now what is my small table threshold? 702 blocks. Now I'm doing an exercise for the small table now. So what is the small table size? 496 blocks. Okay. The same way, let's create a large table. The steps are given here. Now if the table exists already, let me drop it because I've done this exercises a couple of times before this demo. Now I just bump up this table, just make this a little larger. Right. So I kind of inserted 1.6, inserted means it's close to 3.2. Yeah, it's 3.2 million records. Let me commit and see number of blocks it is occupying. Oh, it's large, 7064. All right. Yeah, I don't want to take a table with exactly 703 blocks, then it may or may not fall in this category. To clearly show the difference, I took something smaller, something little bigger than this small table threshold. Now to explain you this, let me start in a first way. So I'm doing here set auto trace on. Let me exit and log back in. So let me flush. So what I'm doing is I'm just doing a select count star from this table. So it showed at the top that there are 200,000 records as expected. And what I'm interested here is the last line here. It does 488 physical reads. So select first time did how many? Now select second time did. Let's run the same select statement again. / and enter. But this time how many reads it does? 0. As expected, right? Because you read all of these 488 physical reads into SGA. When you run the same select, you don't have to do anything. It's already available in the memory. So that's why no disk I/O required, right? If you run member of times, it's available in the memory, right? Now let's do the same exercise with large table. Now let's flush auto trace on. So it did 7070 physical reads. Let me make a note of it here. Select first time did. So I'm assuming that it's also done this IOs into SGA, unless for some reason it proves me wrong. Now let me run the same / same SQL through /. Now my expectation is it should show 0 physical reads. What happened here? It did not show 0 physical reads. Okay, let's thought that's by mistake. Let's run it for the third time. No, it still is not showing 0 physical reads, right? Because nobody else is using this laptop, this VM that I'm working on, right? That's where I got confused. I mean, my initial understanding, I was talking about this table where stuck records and robots, right? If this is a so hot table, why is it not present in a SGA? The answer is small table threshold. To show that, let me do this. Let me enable this NSMTIO trace. Okay. Yeah, before we go there, let me tell you the secret. It is not reading this into a SGA. The disk reads are happening into PGA because the table size is larger than the small table threshold. So that's why you have to read it every time. It's reading into your program global area. So that's why it has to read it. Now let's see the same through a trace. What is this trace I'm enabling? NSMTIO non-smart IO trace, non-smart IO trace. Now let me exit and let me start this with small table. Let me flush. Let me figure out where it is going to write this trace. Let me enable this trace. Okay, let me run the select statement. Now let me VI this trace file. It's not a big file generated, but what I wanted to search here is search with the word nmtio, right? I wanted to look at here no direct read. It is not a direct read. When something is called a direct read, if it is read into a PGA, right? When you see something called direct read, that means it's a PGA. You are reading it from disk to PGA. So when you see here, it's not a direct read, it is read into a SGA. That means your small table is read into SGA. That's why subsequent select statements are coming pretty fast. Now let's explore what it is showing for a large table. Now let me exit here, start this one more time. SQL plus as sysdba. Let me flush the buffer cache and find out the trace enablement here. Let me run this. This is a query on the large table, invoice underscore entry underscore large. I'm sorry, I think in the previous one I showed you the wrong one here. We have to actually look at here, direct read. Okay, so here it is actually reading, doing a direct read. The direct read means it is actually reading it into a PGA. So here it is actually reading it into a PGA. So that's why every time you do the select statement, you have to read it again and again and again. Make sense? Good. So you don't really have to do all these, but think of a scenario, right? Think of a scenario where you do think the blocks are hot, but they doesn't present in, they don't present in SGA, right? So that's where you have to think of the small table threshold. How can you change the small table threshold? Right? It's like somewhere around 2% of your buffer cache. Okay. I think somewhere in Oracle 12 onwards, they change this small table threshold parameter. Prior to that, they have some parameter called very large object threshold. It's somewhere like 500% of buffer pool size, buffer cache size. Yeah, but they change this default behavior of very large, and they introduce a new parameter called small table threshold somewhere in this Oracle 12 releases. All right, let's conclude. Okay, my objective of showing you this video is to show a practical example that it's not always the hard blocks are read into SGA, right? The continuous select reads does not, may not always go to SGA, it goes to PGA, right? So in that robot scenario, what did we do? We actually created an index, right? So that solved it. That's all the I mean, in fact, the index would have been there in a prior during from the start itself, but some reason it was missed. We created an index, and it was a faster, right? Index scan is pretty fast, so that's how we reduced significant amount of IO happening on that production system. With that, I'll conclude this presentation. Thanks for taking time and watching this video. Please comment in the comment section and share your ideas. Looking forward to talk to you in the next recording.